All right, I've got here a perfectly normal glass of water. It is not hot. It's basically room temperature. And I'm going to put them into a vacuum seal container. Got the lid on. I'm going to close the valve. And then I'm going to turn on the pump and start sucking the air out. And you're going to observe what happens. Actually, might zoom in just a tiny bit more. There we go. But I want you to be able to see the valve at the top. And maybe not quite so far. So, let's start this thing. Now, Gay-Lussac, when he went into the high stratosphere on a hot air balloon, realized that he could boil water and stick his arm in it and not get burned because the boiling point of water had gone down. And hopefully we will see this happen today. That noise is the pump which is sucking the air out. As you can see, the pressure is falling. Make sure the valves are shut. Okay, so we're down to about 1/6 of an atmosphere, but we're certainly not to outer space levels. And you can see there are bubbles starting to form in the water. Liquids are really unusual in the universe. Things are usually solid or they're gases, and if you heat up a solid, it usually sublimates directly into gas. But liquids are strange. And the only reason we have a liquid ocean is because the weight of the atmosphere puts enough pressure on it so that once the water is no longer frozen, it can be a liquid before it turns into a gas. But we've taken the atmosphere away, and the water is boiling. This water is boiling, and it is not any hotter than it was when I turned on the cold water tap and poured it. Now, if I stop sucking water out, or stop sucking air out, it quickly stops boiling. And the reason why is the water vapor is, the water's becoming a gas. The gas slowly puts enough pressure on that no more water will boil. It just creates enough gas in that chamber to, it is still bubbling though, but enough gas to produce enough pressure to stop the remainder of the liquid from vaporizing. But if I turn it on again, I'll pump all that gas out and the water will start boiling again. And this is what Gay-Lussac was discovering and was lucky enough to avoid, because a lot of other ballooners would go up and they'd come down dead, with blood coming around their eyes and their nose and their mouth. And it took a while for people to realize that as you get higher, the boiling point of water goes down. Why pasta instructions tell you to cook the pasta longer at a higher altitude. And if the boiling point of water drops below body temperature, well, then your body temperature is above the boiling point and your blood will start to boil. And that's something that Gay-Lussac was lucky enough to avoid when he went high up in the atmosphere. So we'll suck a little more air out and you will see it start to boil again. Remove the atmosphere we created. And sure enough, the water comes back to a boil. But this is not warm water at all. This is water that was the same temperature as before. It is boiling, but it is boiling at room temperature. And if you took it out into space, it would boil away almost immediately, except for a small amount that would freeze because of the heat that went into converting it from a liquid into a gas. So I hope you've enjoyed this. But just to show you once again that I've not somehow secretly heated it up, I'm going to turn off the fan. I'm going to let the air in. Oops. Okay, get a little water all over the place there. Okay, so we did blow a little water around, but I just want to show you that if I take it out, the water is still cold. It is not remotely hot. And since we're under normal atmospheric pressure, it's not boiling either. Now, is it? So I hope you've enjoyed this video, and I invite you to, like and subscribe and all that stuff, but I hope you've enjoyed it. Have a nice day. Bye-bye.